All right, welcome. Good evening, everyone, and welcome to the annual Community Engaged Research Lecture Awards ceremony. I am Monica Kowal, Director of Community Engagement Initiatives here at the University of New Mexico and one of the co-creators of this award. This is the 5th year that the Community Engaged Research Lecture Award has been conferred. It is the second of 2 prestigious awards that are given to faculty who represent exemplary research and creative activity and a cumulative record of achievement nationally and internationally. The Searle Award specifically recognizes the importance of work done by faculty who engage in meaningful research partnerships and collaborations with communities external to the traditional academic areas. Community engagement is defined by relationships between those in the university and those outside the university, and ensures that those relationships are grounded in the qualities of mutual respect, shared authority, and co-creation of goals and outcomes. As UNM is a public research university, it is essential that we recognize those faculty whose commitment to engaged scholarship profoundly and systematically affects the relationship that our institution has with the larger community in a positive and impactful way. More importantly, the Searle Award emphasizes community-engaged scholarly work across the tripartite roles of teaching, research, and service. Nominees and those who are ultimately awarded this recognition are committed to work that exemplifies their academic expertise, work that is mutually and reciprocally beneficial to external communities, work that is visibly shared and collaborated upon with community stakeholders, and work that deeply reflects the public mission of our institution. The work of this year's honoree shows that such relationships by their very nature transcend the disciplines and the college of the university. Dr. Mary Songas of the College of Fine Arts will do a more formal introduction for Dr. Andrea Poli, but I wanted to recognize that this is the first year we have awarded this honor to a faculty member from the fine arts. As we all know, the social impact of the arts and their influence on public engagement cannot be understated. The arts provide settings in which people can discuss issues, form connections, take action. Cultural participation is, in and of itself, a form of civic engagement, and the arts generate both intentional and unintentional consequences that increase both social capital and community capacity. It was Dr. Poli's unique approach to art, media, and technology, and her grounding in public participation and public engagement that persuaded the UNM Research Policy Committee members that she was an exemplar of the engaged scholarship being done by UNM. Scholarship that bridges the divide between campus and community and emphasizes the power of people in place as a vehicle for change. We are deeply honored that she represents our university in such an exemplary and admirable way. I want to thank Dr. David Hansen, Chair of the Research Policy Committee, and all of its standing members for their diligence and commitment to evaluating this year's nominees and selecting our honoree. I also want to thank the Office of the Vice President for Research and for the financial support for this award and the ceremony. And on behalf of the University of New Mexico, I thank all of you for being here tonight to help us celebrate this extraordinary scholar. With that, I will turn over the podium, the mic, to Dr. Songas, who will introduce this year's awardee. Thank you.
Thanks, Monica. Sorry, I'm a little under the weather, so bear with me. I want to thank everyone for coming to the lecture. I also want to thank the Research Policy Committee as well, the members, and for their hard work this year in selecting the 5th Annual Community Engaged Research Lecture. And now, I was very happy to nominate Andrea for this award, and I'm very happy to introduce her as this year's recipient. Andrea received her BA from Johns Hopkins University in art history, her MFA from the School of the Art Institute in Chicago, and her PhD from the University of Plymouth in the UK. She arrived at UNM and has been teaching in the art department since 2009. She has a joint appointment with the School of Engineering, a unique appointment for an artist at UNM and any university. Dr. Poli is one of the most extraordinary artists I know. Extraordinary because she traverses boundaries and works across disciplines, and whose research is deeply, deeply committed to community engagement. Dr. Poli hit the ground running when she came to UNM. As soon as she arrived, Andrea started the social media work group. This collaborative group is very interdisciplinary, involving artists and scientists and scholars in New Mexico who are engaged in conversation and exchange of ideas nationally and more recently internationally. This project began her influential role as mentor to undergrad and graduate students here at UNM. Designed to give students hands-on experience in a variety of relevant skills and technologies, the work group offers jobs and vital technological experience to many, many students. This work also paralleled her notable STEAM New Mexico AmeriCorps Vista program. In its 7th year, STEAM New Mexico has grown from 5 to 20 full-time vistas, serving the people of New Mexico, including over 2,000 underrepresented youth and residents of the Navajo Nation. This remarkable program came out of her involvement in Isaiah International and the International Symposium on Electronic Arts in 2020 called Machine Wilderness. In 2010, only a year after her arrival at UNM, Dr. Poley was instrumental in winning the bid to host Isaiah 2020 in Albuquerque, New Mexico. This was a tremendous achievement since Isaiah is usually hosted in large, notable international cities such as Sydney, Australia, Istanbul, Turkey, Hong Kong, Paris, and Dubai. Isaiah 2012 Machine Wilderness was an amazing symposium that brought people to Albuquerque from all over the world, and it put UNM and Albuquerque on the map. Machine Wilderness presented ideas for a more humane interaction between technology and environment, in which machines can take many forms to support and sustain life on Earth. The project focused on creative solutions for how technology and the natural world can coexist. Professor Poley's leadership style is inclusive, creative, and vibrant. With Isaiah, she was active in bringing together organizations and communities to work on projects that engaged people from across boundaries and across the state. In an innovative and inclusive move, Dr. Poley expanded Isaiah beyond its geographic location of Albuquerque to include the whole state, initiating a process of developing networks that are still in place today. The symposium was a huge success, and some of you may have participated in it, I know that, and I did as well. It was a huge success, winning Dr. Poley an Albuquerque Meeting Heroes Award and a Bravos Award for the symposium. Working at the intersection of arts, science, technology, ecology, community engagement, and as a social practice artist, scholar, and educator, Dr. Poley's work has made noteworthy contributions and has influenced the field of art and ecology. Her incredible large public installations, Particle Falls, and I know she'll talk about this, and more recently, Energy Flow, which was installed on the Rachel Carson Bridge in Pittsburgh, show that Dr. Poley is truly a rare and outstanding artist and researcher in that her collaborative methodology brings together local communities, educational institutions, and professional organizations in whatever geographic location she works in. More recently, Dr. Poley's Biocultura Community Arts Project has deepened the range of community engagement in her work. Biocultura has a mobile component that travels and engages local communities in New Mexico and beyond. The module that is based in Santa Fe is dedicated to connecting central and northern New Mexico communities with artists and scientists from here and across the world, farmers, environmentalists, indigenous experts, and city planners. The project has been supported by the New Mexico Consortium Project Grant, an exhibition grant from Idea X Factory, and has received multiple awards and extensive press coverage. As a mentor, Dr. Poley is outstanding with students. Andrea's students from her bio-art class recently presented their speculative design project called BioShield at the Biodesign Challenge at Parsons School of Art in New York in June. And then the project was selected and presented at the Global Community Biosummit at the MIT Media Lab this past October. Lastly, I want to say that I admire Dr. Poley's deep environmental concern and her dedication to investigating climate change and sustainability issues. The problems we currently face are thoroughly examined in in her examination and often culminates in her inspirational work. She is able to create artwork that engages, educates, and inspires people to consider that we are all in this together. Polly's projects are successful. They are grounded and affect change in the community she engages and locations where the events and projects happen. Her work reminds us that cross-discipline and community-engaged research and collaboration will result in amazing new possibilities that will help us figure out strategies for our survival. Without further ado, I'd like to introduce Dr. Andrea Polly.
Thank you so much, Monica and Mary and Regina and Susanna. And it's, just to emphasize what Monica was saying about how much community engagement is involved in the arts. And I just think it's wonderful that this avenue of recognition for faculty is available. And I love to see where this goes in the future, because I can just think of so many people, new faculty coming in, they're doing incredible work throughout the community. I could never have done the work that I've been doing without the opportunities and the vision that came to me from, sorry, I should move away from this, that I received when I came to UNM. As Mary mentioned, this joint appointment between engineering and art, and also the Mesa del Sol Endowed Chair of Digital Media. And that has been what has allowed me to start, a small amount of kind of seed funding to start a lab and move forward with the work. And I can't emphasize enough how important that is in the university, and how much it would be great to see more of that kind of happening, and more of that support. So as Mary said, my work is between science and art, and a lot of art and technology, but I think in a effective community engagement doesn't need to have that technology or that science or that interdisciplinary manner. There's a lot of people working in the fine arts that are not using technology, that are doing incredible community engagement. In a lot of ways, I think it might be easier to do that, or you might be able to engage the community in an easier way if you're not involving technology. And I think as I was reflecting on the work that I have been doing, a lot of it has been making that technology more accessible to people somehow, and trying to make it a little more seamless, and I'll talk about that. So I started this social media work group with the Mesa del Sol Endowed Chair. It allowed me to hire students to work with me in my lab, and to work over the course of several years. So most of the students that I've worked with, and now I've worked with maybe 20 or 30 students, they work with me for more than 1 year, and most of them will work throughout their entire career. They'll start as freshmen and as first year, and graduate as members of the lab. And that's a really unique thing. I think that might be not so much in programs throughout the university, where you actually get to work closely with the students on research projects for that long of a time. And I think that's something important that it would be great to see in more places. So the theme of the lab, or the idea that I came to the lab with, is this quote from Mark Weiser, who is a pioneer of ubiquitous computing. He said this in 1991: "There's more information available at our fingertips during a walk in the woods than in any computer system." And I broke this down into some kind of research questions. What are the social and cultural effects of defining the natural and man-made environment as information space? And remember, Weiser was talking in 1991 and speculating that we might all have computers, and computers might be ubiquitous around, and we didn't necessarily believe that, but now, of course, we all have very powerful computers just in our pocket. How can and should a hybrid social media practice emerge and engage with the arid desert environment of the American Southwest and beyond? And what kinds of mobile, locative media, and ubiquitous computing platforms can help users engage with this environment? And how can this practice connect and extend to communities globally? So I kind of started out with this lofty ideas, and we were going to be researching all these questions. And I think we really have in a lot of ways, and we have addressed some of these issues. But this, I think, has become more our motto. And this is a quote from one of the research students that I've had who's now working for Apple doing augmented reality stuff. And he said this in an interview. Technologically, we had no idea what we were doing. And I love this because in a way it's kind of funny, and it's how we're doing things by the seat of our pants, but at the same time, it says what students want to do. And what do students want to do? They want to do what they've never done before. So this just to give you a flavor of some of my research group a few years ago, working on Navajo Nation. We did a cell phone tour across looking at the issues between two of the largest coal-fired power plants in the country that are located on Navajo Nation. We interviewed activists, a medicine man, and other people on the reservation. We worked with Vinaya Yazi, a Navajo artist, to kind of build this cell phone tour. Okay, now I'm going to back up. So I came to UNM. I had been doing projects related to air and atmosphere and climate change and weather. I was really interested in weather. And I did some pieces that were using air as a medium. This is a piece called Breather. It's a balloon around a car that contracts and expands over the course of about a minute, as if it's a plastic bag over your head and you're trying to breathe. And this was inspired by doing a residency in Delhi, India, where I literally felt like I had that bag over my head. I also did several vehicle kind of works. This is another one. This is a sketch of the mobile version of a piece called Cloud Car, which is a car fitted with a mist system. It was inspired by Diller and Scafidio's Cloud Car, and here it is at the New York Hall of Science. And what we did with this, as well as with Breather, is the piece would be shown, and then people would be stationed near the piece with some kind of information sheet. If you have to drive, what can you do to reduce your emissions? If you could see your emissions, this might be what it looks like. And it was a way to kind of open up things to the community to say, let's have a conversation. And it was interesting because it did, we did have big semis kind of pulling up next to this thing, and we'd hand them a fact sheet about emissions, and they'd say thank you. And you imagine if you were just handing someone a fact sheet about emissions without something like this, they would not say thank you. So this piece is called Cloud Car, and when I first showed it on the streets of New York, we attracted New York's bravest, the fire department, and this I always loved. I just have to show this slide because it's like my proudest moment as an artist. They put the Cloud Car sticker on the fire truck. We talked a lot about water propulsion. They first thought it was on fire, but when they learned it was water propulsion, they got really interested in. And the mist then also served as a platform for telling stories, so projecting words on the mist system. So those were the kind of things that I was doing before I came to UNM. Right before I came to UNM, I had the opportunity to go to Antarctica on a National Science Foundation grant. These are some of the scientists that I work with. I worked alongside atmospheric, biological scientists, did a lot of recordings, mostly followed the scientists around the dry valleys, documenting these 17 weather stations that are part of the long-term ecological research project in the dry valleys. And so this is an example of one of the weather stations. And the results from that project included an audio CD of sound recordings and data sonifications and interviews with scientists, and also a book that I co-wrote with Jane Marshing about how the tools of artists and scientists in the field are converging with digital technologies. So I got to UNM, and I had started a project where I had these weather stations, these kind of semi-professional weather stations, and I wanted to share that data at community centers kind of around the world and see what people would do with the weather station data, to show people how to use the data and share it. And this is the project Hello Weather. The data ended up being shared on a website, so you can see on the right there all the different data sources. Weather stations were placed in a whole bunch of different places kind of around the world. In Switzerland, there was one in Delhi, India. The longest running one is still running at Debs Park in LA, but there were ones that were temporarily there. And that created a whole investigation into where are there community operated or amateur weather stations around the whole country. And I got connected to this CWAP network, and also Weather Underground and Anything Weather and some other things. And so at the same time, I'm working with students from computer science and IFDM program, and we're just talking about, well, what do you want to do? And they came with me on some of these trips to put up the weather stations and stuff, and what might you would do with this? And this was right around the time of the Internet of Things, where you had objects tweeting. One of the more famous ones was the Tower Bridge in London was tweeting every time it went up and down. And so one of my research students said, well, let's get these weather stations to tweet. And we thought, well, maybe it's not just the 5 weather stations that we have, maybe it's all the weather stations on the weather network. And so the students really worked to figure out the Twitter API and create this. We found over 2,000 quotes, under 140 characters, 140 characters at the time, quotes about the weather that we created into a database based on what kind of weather it was referring to. And we created atmosphere. You could log in, you could subscribe to a station, anything on the Weather Underground network, and then once a day you would get this tweet that was a famous quote about the weather that tied into what that general weather was for that day. And it was a really fun collaboration and a fun start to trying to understand what our students want to do. And a lot of this mobile media has been a major theme in the kinds of things that the students want to do, and in order to connect with people. So soon after I had been doing a lot of stuff with the weather stations, I learned that there were some really wonderful pieces of equipment that can measure particulate pollution in the air. This was also about the same time that I came to UNM, about 2009. And so I connected with Met1 Instruments and got this instrument donated. Pretty expensive, like not a consumer grade, about a $15,000 instrument called a nephelometer. And it measures using a laser in real time particulate pollution in the air, and specifically particulate pollution that's very small, easily lodged in the heart and the lungs. And use that instrument to create this piece called Particle Falls. And as Mary mentioned, it's a beautiful blue waterfall when there's no particulate pollution. It turns into a fireball when particulate pollution is visible. And I'll just play a little video to show you. All these videos have been created by students in my lab as well. And most of the videos have been created by Jared Rendon-Trompak, who's been with my lab for a long time and is a fantastic videographer. He's now staff, and he's graduated from IFDM. And the music is by another research student who has an independent label. So just oops, sorry. So before I move past this, I just want to say, so one of the nicest opportunities that we had with Particle Falls. We showed Particle Falls in many different places around the US, and also in Germany, and other places in Europe, and most wonderfully in Paris before the COP21 climate conference, where the historic climate agreement was signed. And students have gone, in my lab, have gone to all of these trips. And I just want to say, this is really nice, like reflecting on working with students for this talk, because these are things you never get to talk about in Artist Talk. So we were going to the airport, and we were all meeting at like early in the morning at the airport to go to Paris to do this piece. And one of my student researchers was there, and he was there with his parents, and his parents were standing, with him, and as we were leaving and stuff. And I always think about my research students as kind of peers, and we act like peers and behave like peers in the lab. And so I was kind of confused about that. I was like, is everything okay? What's going on? And so, his parents, I said hello to his parents and stuff, and they left, and I realized he had never been out of the country. And this was his first time. And I was just like, wow, I sometimes kind of speaks maybe more to like how I'm maybe not as connected to the lives of the students, but that I just think it's wonderful to be able to provide those kind of opportunities to students. So soon after, a couple of years after I arrived, I was fortunate to be on a National Science Foundation grant with engineering professor Olga Lavrova, who does a lot of work with solar energy. And this project called Septet, there were 7 PIs. And we did a lot of outreach related to that project. Here we are in Taos, where there's a 1-mile experimental solar field that was created. We had high school students up in Taos meet with our students in the computational sustainability class. We've also done outreach work with the Café Scientifique, or science cafes, with high school students in an after-school program at libraries. And we started to continue, we continued the work with particle falls and with particulate pollution measuring. And just a few years later, this instrument came out. And this instrument costs about $300 to buy and probably less than $100 to make with a 3D printer and electronic parts. But it does the exact same thing as that $15,000 piece of equipment does just a few years later. So this was really a sea change that happened. I think a lot of my students anyway saw that it was going to be happening, but it was a surprise to me. I started to think about how using these kinds of tools, these microprocessors, these kind of very inexpensive tools, could really help to help people to understand energy systems. The Septet project was about how energy systems can be more efficient, how communities can better understand clean energy or renewable energy. And so the framework for that I've been talking about quite a bit was called Hack the Grid. And you hear a lot of like negative stuff about this hacking these days, and the idea, to hear the terms hack the grid, you immediately think of like cyber warfare, and that's not what I'm talking about here at all. I'm using the term hack to make your own, create it, and these are some of the more traditional definitions of hacking: creating and sharing, hostility to secrecy, the right to fork or share your code or share your work, distaste of authority, freedom of inquiry, sharing as ideology and strategy, emphasis on rationality and playful cleverness. And in a lot of ways, those ideas will merge a lot of things. They'll merge people who are working in electrical engineering, who are designing chips, and students who are designing chips, working with microprocessors, students in computer science who are doing programming, and also people who are just fixing their washing machine, and just interested in that kind of hands-on understanding of their lives around them. So we use the air beam.
Here's the top search result.
Oops. We use the air beam for this project, a horizontal version of Particle Falls, which was presented in Zagreb, Croatia at the Museum of Contemporary Art. They gave us a short residency. We used 3 of the air beams and a different free open source application to create the animations. And again, responding to air quality in the local environment. I'll just show a little bit of that. Another thing, so that piece involved, you see those wonderful LED panels. That was permanently installed in the building, and they have different artist showpieces on those LED screens. And so we became really interested in like that LED technology, which is another technology that was really growing and really becoming a lot more accessible and a lot more inexpensive for our projects. And so one of the projects that we did with Septet was a project called RAIN, which is a visualization on the solar decathlon house that UNM built in collaboration with Arizona State University. And this is up on the Mesa del Sol space. And you can see, so that the house was what they built, and you can see, we put these LED strips on the solar panels to highlight how the solar panels were collecting power. And then there was an animation that we created on the LED strips to show that the use of that power, how much power was being generated. It was a very simple, very early piece, and these are maybe, 8 feet long strips. And they were really inexpensive to get. We ended up reusing them a lot. We put them up in Taos as part of Taos Paseo, visualizing different things. And now you can actually see them at the Center for Advanced Research Computing, where we have them outside. And we started using these strips a lot. We've got a larger installation on the windows to the Center for Advanced Research Computing. And we got 20-foot long strips for the Balloon Museum. In 2014, we started this project. It's still going. And every year for Balloon Fiesta, we're looking at the animation that's on there and do we want to update it and how do we want to change it. The first one that we did was text interactive, so people could text the piece and get different animations. This animation is responding to local wind speeds. So if you have too high of a wind speeds, you can't fly a balloon, so we are showing red or green for that. So I want to show this in the context of how these projects really can scale up with pretty much the same equipment and skills and materials. So after doing a few of these LED projects, from 8 feet to 20 feet, got an opportunity to do a project on the Rachel Carson Bridge, which is what the mayor of Pittsburgh has now named the 9th Street Bridge in Pittsburgh. It's part of these Three Sisters bridges. They're all 3 the same design. The project was designed to run entirely on wind power. So it worked with a local wind power company called Windstacks, who created these beautiful custom wind turbines, and worked with students and former students, Chris Clavio, who's on staff at Meow Wolf. This is Eric, who had that great quote in the beginning, who's now at Apple, and 52 microprocessors, small computers. The same exact thing that we use at CARSI or anywhere else, except this time we're 900 feet and 60 feet tall with LEDs. And we put these cans of light on the top. We just worked with a local Albuquerque sign company. We put these cans, circles, and the rest of it was LED strips. This was a temporary piece for about 2 years on the bridge. Lots of workshops that were done around that, lots of educational material about the potential for wind power. The wind power company that I worked with had already done a feasibility study for wind. So the LEDs would animate based on the wind power potential in that area, and the entire bridge powered not only, well, the power was given back to the grid, and but it produced way more power than the lights needed, which is really incredible. And that's the incredible thing too about these LED strips. They're really inexpensive, but they're also relatively low power consumption. And then what's been nice too is that we've been able to reuse a lot of the materials. So the controllers and the computers we've now repurposed to a permanent piece in Pittsburgh, downtown Pittsburgh, called Garrison Canal, which turns Garrison Place, which was kind of a forgotten alley in Pittsburgh, into a kind of place where people are way into taking selfies. It's kind of crazy. And the animation responds to real-time weather, temperature, and precipitation, so it's always changing. So that's the one thread. I mean, I said I was going to have 2 threads. So that's the one thread. The other thread, I think for the purposes of this presentation, starts with ICEA. So Mary had talked about ICEA. ICEA is the International Symposium for Electronic Art. I had been involved in it for many years before coming to UNM, and I thought it would be so wonderful if an ICEA could be in Albuquerque and in New Mexico, because it's such an interesting place that is intersecting the sciences and the natural world, and a really deep connection to the arts, and like how do all these things go together. So I came right around, if you remember, there was a project called Land Arts that was led by 516 Arts. And they had a bunch of different partners, and they had projects in Taos and different places. And I was there, and I was like, oh, well, I'd love to propose a large-scale project, but I need help. I don't know anybody in New Mexico, barely. And I found out that Suzanne Sparge of 516 Arts was like this powerhouse that could really connect a lot of partners throughout New Mexico, throughout Albuquerque. So I went to Suzanne, and I said, you know, do you want to partner with us to do this? You know, be our executive director, and let's make this happen. And she said, yeah, great. So we did it. It ended up being about a $3 million project going across New Mexico, also down to the region, and places outside of New Mexico. And we were looking at, you know, I had done all these car projects, and so I was kind of into like getting some car projects out here too. And so we had some great projects like this SEFT project by a couple of artists in Mexico who had actually taken this thing on, it will ride on rails and on highways, and has taken it to cities around Mexico that had been cut off from really other communities in Mexico, because the rails had become disused, so they were able to like kind of see those communities and talk to people about their needs, and help to promote what they might need. My colleagues, Jen Hartman with Chrissy Orr, created the Seed Story that was also part of it. Lots of these car projects. Amazing Lowrider Symphony was created by Chris Marinetti, who's a New York-based artist. Had done these car symphonies, but not a lowrider symphony, and so he, through our project, he was able to connect with some lowrider car clubs and do this incredible performance right in downtown Albuquerque. And also some artists from Brazil who are creating vehicles out of scavenged materials. And of course, our students. So our students had opportunities to volunteer at ICEA. They had opportunities to present at ICEA. Here they're meeting with a couple of artists from, they're all in the orange t-shirts. And they're meeting with a couple of artists from New Zealand who did a lot of presentations. And then, like I said, we went down to, this is in El Paso at UTEP, our art museum, where the students got a chance to do a project with an artist there. And also up in Taos, where we were, Paul Van Aus, who's a professor at the University of Buffalo, was invited to do a project with a certain bacteria that lives in the hot springs there. And Paul Van Aus is well known for some of his projects taking these genetic maps and making them look like whatever you want them to look like based on the chemistry and the way he's doing it. And he's trying to emphasize that the lab work is, has a certain level of creativity, or there's certain things that you can do in the lab work that can make things look differently. And sort of, questioning this or opening up a conversation about these biology and art. And so I became inspired by Paul and other people around that time, and started to investigate bioart and how that might play into some of the things that I'm doing in my classes and with the lab. And so I had the opportunity to be part of the inaugural workshop for Alvar Aalto University, who created a bio lab just for artists, a high-end bio lab. So here we are with Oren Katz, and who is part of Symbiotica in Perth, Australia. They created a PhD program for bio artists. So they're inaugurating this lab in Finland, and we're culturing mouse cells. They're showing us how to culture mouse cells there. This is Yonat Sur, Oren's partner. Also, they collaborate and show the lab things. And it became really interesting to me what was happening on the DIY bio side. So I had this whole thinking about hack the grid and hacking on computer technologies, and I realized that there was this whole world of DIY bio out there, and DIY bio being done by artists, by individuals in the community, and for many different community purposes. There's a lab called Hacteria in India that figured out a way to genetically modify a bacteria to glow in the presence of arsenic, and they have large problems with arsenic contamination there. So people in the community are able to inexpensively grow this bacteria and see what's happening in their environment. So I had the opportunity to collaborate with the Vogue Society in Amsterdam, and they are still running a international online course called the Biohack Academy. So they will get a partner of a school or a community organization around the world and offer this Biohack Academy. It's a 10-week intensive boot camp where you learn a combination of microprocessors and programming, 3D printing and laser cutting, and biology, and you're using your knowledge to create biological equipment that you can use in your lab. So this is one of their hacked centrifuge machines that's 3D printed, laser cut, and includes some really basic and inexpensive electronics. So instruments like this is a similar kind of thing to the air beam and the nephelometer. Instruments that would cost, tens of thousands of dollars can be built for under $100 by students, and at the same time they're learning all these really essential skills. So I just loved the Biohack Academy. Not only that, but the students collaborate with each other internationally. So the last time we did the Biohack Academy, we were collaborating with a student group in Japan, in Tokyo, in Korea, and in Denmark. So there's a great opportunity there. So I started doing, kind of setting up some of my own labs. This was at the Vermont Studio Center, playing around with different things. I was inspired by Susan Lee, as an artist who creates what she calls biocouture. So she grows basically kombucha mothers to make a kind of a leather, a vegan leather. And so I experimented with growing these kombucha mothers and drying them and sewing them and making screens out of them and collaborating with my partner, who's an architectural designer, John Donalds, to make structures in which we could highlight aspects of biology. So this is a piece called the Bio Kitchen. It's modular, and inside of the Bio Kitchen we would hold events about biology and kitchen technology. This structure is now in the courtyard in the UNM art building, and students have been using it. I was just communicating with a student who wants to do some things there. And then we made another structure called the Tea House, and it's a 10 by 10 structure designed around the concepts of the Japanese tea house, and have shown this in a number of different places. First in Springfield, Missouri, where there happened to be a Japanese tea master who wanted to do a ceremony in the tea house. And the tea house, like the Bio Kitchen, is kind of a framework structure by which we can share ideas about biology. So for example, in the tea house there's microscopes, and people can look at leaves. And in fact, another funny story was that when we showed this and we had local plants that people were making tea out of, and we just had the plants sitting there. I had a young person, 20 or so years old, came up to me and said, "Wow, I never realized that tea was made from leaves of plants." Which is really, I didn't think that it was such an important thing to say to people. Traditionally, outside of a tea house, a Japanese tea house, there's a fountain. And we use that opportunity to make an aquaponics system and just kind of get people to know about that. So what we learned from making all these huge structures is that it's a pain to move around really huge structures. And so we decided to get we found a badly fire damaged adobe in Santa Fe, and we decided to make that the home for Biocultura for a while, and we called it Biocultura. We decided to make that the home for bio art projects in the community for a while. We've now moved away from this structure, but I'll just show you some of the things and talk about some of the things that we've done. So we worked with a wonderful photo mural artist named Chip Thomas, who created the murals that you see on the house. They're still there, and they're photographs from Hopi, young Hopi farmers. Chip Thomas is the artist that created one of the People's Climate Movement posters. He's based on Navajo Nation. He's been there for about 35 years. And our first opportunity with Biocultura was to collaborate with the Smithsonian's Earth Optimism Summit. So they had, over the course of a few days around Earth Day, they created this summit that was webcast. And so our contribution to that was in New Mexico, in Santa Fe. Chip made the poster. And we did a number of different talks and a number of different events, and ended up being about 10 community events at Biocultura. This is Mick LaRusso, who did a workshop for community members and our students on batteries, how to get power from biological structures. So I like to show this one. There's a whole bunch of other ones. I like to show this one because it kind of is bringing together that idea of sustainable energy and the bioart and the biohacking stuff. But many different things that we've done, from anywhere from a neuroscientist leading a sleepover at the house, to fermentation workshops, to baking bread, to an artist actually digging up our sewer and performing a ritual around our sewer, which was really interesting. So kind of trying to tie this stuff together, and I know it's a lot of loose threads, but that's kind of the only way I could put it together. ICEA brought together about 90 different partners all across the state, and it was wonderful. But after it happened, it was a 4 or 5 day symposium. It became really hard to keep those partners together. There was a lot of different things going on, and it seemed to me to be really important to try and keep those partners together. So I made a proposal to, and actually the way this went down was maybe a little different than I'm framing it. The SEPTED grant ended, the National Science Foundation grant ended. It was really nice to have that grant because I was able to hire a lot more students. And so I wanted to try and write another grant. And I found out that the AmeriCorps Vista program, you could hire people and they could work on capacity building, and which could be grant writing. So I went to the New Mexico office, which no longer exists. It's now a regional office. And I said, I'd like to get one Vista to help me write grants. And they said, well, it's actually not worth it for us for you to have one person. You have to have at least 5. And so I was like, okay, let me rethink this whole thing. 5 full-time people, what are we going to do? And we ended up creating STEAM New Mexico in, 6 years ago now. Amy Pilling is now a part of that. She's here, cringing at her photo, I'm sure. At the Discovery Fest, which there'll be another one coming up here this week, Friday. STEAM New Mexico is, and Amy is working with Biocultura and other initiatives that we have in Santa Fe. Our Vistas, this is a Vista group from about a year ago. There's 1 or 2 that are, there's one that's still on now, and there's some that are here. Jen so we ended up partnering with, so the only way to really do this, direct 5, 10, 15, 20 full-time people, is to get partners, and really serious partners. So we started to where we were based at Carsey. We're so grateful to be able to be at Carsey and do the work there. We were partnered with 516 Arts for a while. We connected with CNM, and at that time, some of you probably know about the CNM Ingenuity Project, Fuse Makerspace, the Stimulus Center downtown, and workforce training. So we've partnered with them really at the beginning. Fuse Makerspace, before it was downtown, was on the CNM campus in a faculty member's classroom, basically, and didn't have any full-time staff. So we provided the first 2 full-time staff for Fuse Makerspace and really helped them to grow to what they are now, which is pretty amazing. We also have vistas with the School of Architecture and Planning here, STEM Arts Lab in Taos, which became a bouncing off point for the Paseo Festival to become a not-for-profit, and now Paseo is sponsoring vistas. So some kinds of projects that we do workshops in my lab at the Center for Advanced Research Computing. This is Scott Kildall doing a workshop where the students are creating a simple electronic circuit and putting it in water of different qualities, different metal levels, and they create different tones and sounds based on the level of metals in the water. This is one of our previous Biocultura Vistas, Madeline Bolding, doing a DNA extraction at Explora. This is Agnes Chavez, who's one of our first Vistas in Taos. And then we've been able to connect the student work to the Vista work. So this is a piece that my students created for Taos Paseo. So I'll just play, called the Glow Pod. And it's been also at Explora and at the School of Architecture and Planning for Arts Unexpected. So this, again, I guess things are starting to kind of converge. It's sometimes so difficult to bring all the threads together. But in this case, we worked with Red Willow Farms, which is on Taos Pueblo, and it's a group that's trying to revive some of the traditional plants. And so we were able to include the traditional plants inside of the structure, and then the lights are tied to the moisture level and the temperature of the plants. And one of my students really wanted to do VR work as part of his portfolio, so we created a virtual reality that takes the Glow Pod into outer space, bringing these traditional plants there. I know it's a structure again, but we haven't stopped building structures, and I think one thing that we've learned is to make them as easily portable and as modular as possible, which I think you'll see in a minute, I hope. Yes. So. Yeah, this whole thing fit in Amy's trailer, and we lugged it up to Taos and around to Explora and some other places, and could put it up in half a day. So, some stuff we have going on now. I remember I pointed out those cans on the top of the bridge, these made by the sign company, and you thought, why is she telling me about this? We actually have been able to reuse those here in Albuquerque. So we got 52 of those back from the bridge, and one of my students was taking a course in complex systems, and he learned about the game of life, and he thought, well, let's try putting this simple rule set onto an installation, which we have now up at the Box Theater on Gold Street. So you can drive by and check it out. There's also a QR code for a simulation that you can play with yourself. So right now I'm working on a public piece for the California Air Resources Board. They are building a new center there kind of the watchdog for air quality out in California. They're building a new complex in Riverside, California, and I'm building a piece for the front green, which you can see. These are just the models of what it is, and it's a shape inspired by particulate molecules that will light in real time, show air quality in real time. And in a lot of ways, I'm really proud to be able to do a piece like this for California now, because of what's happening with the fires. And the issues are really big. California Air Resources Board is dealing with this quite a bit. So I'm happy to support that with this piece. So let me just end with a couple of things. The Hack the Grid is also, there's a book that's called Hack the Grid that the Carnegie Museum of Art put out for me, and there's a manifesto in it, and I'm just going to whip through the 10 main points of the manifesto, because I think maybe that speaks to how some of these things become connected to community. So what do you do if you want to hack the grid? Be a grid hacker, learn as much as possible about how energy systems work, know how much energy you consume and its environmental impact, demand that energy providers tell you the source of the energy you purchase, learn how to use the technology around you to gather information about your world and environment, learn to create a basic electric circuit, use a multimeter and read a circuit diagram, learn to write a computer program, learn to harvest energy from the sun, the wind, the earth, and your body. Don't be a passive consumer audience of images, media, or technology. Understand that your life is inextricably intertwined with your use of energy in all forms. Learn from what others have done. Share your experiences and build your own communities of grid hackers. And so that's just a part of the book. There's a number of different interviews with other labs that are doing pretty amazing things in environmental outreach and working with community. Really a computer science lab, specifically the CREATE lab at Carnegie Mellon, which if you're not aware of it, definitely check that out. And I'm just going to end with, I hope, a real low-tech thing that we did in Arizona. This is the human machine. And something that we did at the beginning of a workshop to kind of break the ice. And that's it. Thank you.
Okay, thank you.
Sure.
So we
Questions?
have a few minutes for question and answers. There's a microphone here if you would like to. So that other people can hear you, or if you want to just ask a question, we're more than happy to take it for a few minutes.
So I just want to recognize our Vistas former and present. So Brittany King is here. She worked with Fuse Makerspace and also at CAR-C, and is a graduate of UNM and now a UNM MFA student. And Jen Diaz, JD, had completed a year with our Vista program with workforce training, and is a graduate of UNM art department. Yeah. And of course, Amy Pilling, who is on her second year of a Vista with Biocultura, and has a project called Life Arts Laboratory, which is a mobile DIY bio lab. So talk to her about that project. It's pretty amazing. And talk to Jen and Brittany about their fantastic interactive artworks that they do. So I think that's everybody who's been at Vista. Yeah.
Can you stand up and
Yeah.
Okay.
So my question then was, I noticed that a lot of the exhibits that a lot of the students in the program have built, they're really moving around to different regions and countries and parts of the world. And do you think the nature of this work is inherently able to transfer easily across different places? Or do you think there's even more room for it to grow where it can be really regional and very specific to certain geographic regions?
That's a really good question, and I think there's a couple directions that an answer could go. you know, a lot of these projects have sensors attached to them, so there's a real need for a local gathering of data, even to just make them work. But every region, you know, has their own kind of local situation. I think the other thing with the media artworks is that the equipment in which to run them on can also be local to wherever you're going. So like Particle Falls, we decided not to get a big projector and bring that around to all these different places. We would go, and then the venue would rent the projector, and we would just bring our small little microcomputers and show that. So I think it does make it easy to move around. And the other part of your question is about, making them local and real. Yeah, and so I think the projects like the one on Navajo Nation that's using, you know, GPS, and you really have to, the only way to experience that is to actually be in the space. And as you're driving, you're hearing the stories of people whose lives have been impacted by those coal-fired power plants. So I think that's definitely a way in which technology then can become like hyper-local.
Hey, thank you.
Andrea, your work is great. I really enjoyed your presentation and hearing about it. It seems like almost all of these installations are temporary, and I want a bunch of permanent ones all over campus. So
thank you.
Speak to the nature of the temporal issue of your work.
Yeah, I mean, I think it would be great for them to be permanent, for sure. But it's often the case that these kinds of projects, because the technology is so new and kind of unproven in the permanent public art world, that it is sometimes difficult. So I have a piece that I put up in 2011 that's a permanent piece at the University of Utah. It's inside, it's LED panels. We had to replace a few panels, you know, once, but you know, it's still going strong, and will still go strong. So you know, I think public art supporters and promoters need to understand a different kind of maintenance maybe that needs to happen with these kinds of things. I mean, certainly the bronzes and that, you know, they all have a maintenance thing that's important. So it's just a different kind of maintenance for these kind of projects. But yeah, I mean, who knows? The bio kitchen in the courtyard of the art department is there for a long time, as long as Susanna lets us keep it there. So, you know, and that's been the thing with a lot of these projects too. It's like you put one up, the piece in the alley in Pittsburgh was intended to be a 2-year, we got a 2-year contract to do that piece. They want it now to be permanent, and so we're talking to them about, you know, what that would take. Yeah. Yeah.
You know, with that project in Pittsburgh, I saw in one of your images that you had like a little explanation added to the bridge.
Yes.
Project, and I thought that was really important in order to really understand the layers of your work, that they're not just visually captivating, but you know what actually is going on there.
Yeah,
and
I agree.
think that's valuable if things become permanent, to really think about how to communicate beyond the visual, emotional, aesthetic element of the work, of how else can we communicate what this actually visualizes, which is an essential concept of everybody's life.
Definitely, yeah. And a lot of them have, you know, will have an online component too. So in the case of that, the bridge project, people could go online and they could see how much energy it was producing and that kind of thing. So there's more of a dynamic information too that people can research. Yeah. Okay, thank you. Oh.
So now we get to the actual award section of our ceremony, and we have Derek Hamilton, who is the Assistant Vice President for Research in the Office of the Vice President for Research, to present Dr. Poley with her awards. So go ahead.
Thank you. Thank you. I want to thank Dr. Poley for just a compelling and wonderful lecture, and thank all of you for coming and attending. To say a couple of words about community engaged research that I think are really well reflected in Dr. Poley's work is the potential impact, not just on the individuals from the community who are working on research projects with UNM faculty, but also I think just very compelling how your work on what I view as visualization of data, right, and communicating and translating information that might otherwise go unseen or not land on an individual and have an impact on their life and their behavior. How and I mean to say this with the greatest respect, a simple sort of interface for visualizing data can have a very profound impact on how people view the world around them, and I think that's just wonderfully captured in your work. And with community engaged research of the type that Dr. Poley's involved in, helps UNM meet our mission as a flagship research university, and helps bridge our community and our university together. So it's with great pleasure that I present the 5th Community Engaged Research Lecture Award to Professor Poley. And we've got a citation and a physical.
Thank you so much. This is really beautiful. Oh, okay.
Otherwise I'll have to just Photoshop it.
Yeah.
Don't want to have to Photoshop.
This is so beautiful.
Perfect. Ready? 1, 2, 3. 1, 2, 3.
Thank you. Wow.
Thank you.
Thank you.
So congratulations.
Thank you. Who made this? Do we know? It's beautiful. Thank you.
Thank you. So for those of you who are familiar with the campus, the STEM Commons Room is in the Centennial and Engineering Building, which is this way. If you cut across the parking lot and kind of follow the pathway, you'll see the STEM, the Engineering Center, and you'll see the STEM Commons Room, which is right on the inside. There is lots and lots of really good food there. So waiting for all of us to come, and beverages, and just a time for us to interact with Dr. Poley before she leaves for the evening. So thank you all for coming, and I appreciate your time.
Thank you. Let's eat.